I'd like to go over a few differential equations practice problems. If you haven't watched the previous video, please go back and watch that one first. Right now, I would like you to try to do this problem best that you can on your own. Please pause the video and give it a try. So for the first one, you're sketching a slope field. My recommendation is to either draw a table or you could just do each point in your head. So like, for example, if you choose the point -1, 2, when you plug that in for that differential equation, you will end up getting a +1 over 2 times 2, which is 4. And you could see it -1, 2. It's not perfect, but just try to get it the best that you can. It's rare that you'll actually have to draw one of these. More likely you'll get a computer-generated slope field. If you do have to draw one, they're mainly going to look for how the slopes of each thing compare to the other. For part B, you are asked to sketch a solution curve that goes through the point 0, -1. And this one, sometimes I get different answers. Keep in mind that we have here that you can assume that the solution curve is a function, which means it's not going to be like a circle or anything that has two y values. So the point 0, -1 is this orange one that I drew right there. Whenever you have a little line with a 0 slope, that is a sign that it's likely to be like a maximum or minimum point. You're going to kind of try to follow how the other slopes are. And you'll find that this one is like the bottom half of an ellipse. So for part C, I asked you to find the particular solution to the differential equation for 0, -1. And we are going to take that differential equation right there, and we're going to do what's called separation of variables. So I'm going to start by moving over the 2y to the left side with the dy, and I'm going to move over the dx to the right side with the -x. Actually, you should never have a dy or a dx on the bottom of a fraction, so that by default, the dx is always going to go to the right, and you're going to get all your y variables to the left. Once we do this, then we are going to take the integral of both sides. So I take the integral of each side. The antiderivative of 2y dy is y squared. The antiderivative of -x dx is -x squared over 2. Technically, you should have a constant of integration on both sides, but rather than doing a plus c over here and a plus c over here, we are going to accumulate all of our constants of integration onto one side. And you will generally find that your life will be much easier if you do it on the side that has the x. It's really important that you make sure you add your constant of integration on this step. If you add it at the end after you've solved for y, you're gonna run into problems. So I'm actually gonna write out the steps. So the first thing is you're gonna separate the variables, and then you do the antiderivatives, and you do the plus c. Just so you are aware, this is frequently a AP free response. The 3 little points that I made are generally, each of those is worth 1 point. Sometimes the antiderivatives is worth 2. So if you forget the plus c, you often will, you'll lose several points usually. At this stage, you are going to want to use your initial condition, which is the 0 -1. And we use it by plugging in -1 for y and 0 for x. And if you solve that out, you are going to get c is equal to +1. So once you have that, you're going to then plug the c back into the equation that you had right there. We get y squared equals negative x squared over 2 plus 1. So that was the step where you use the initial condition. That generally is worth a point for the AP free response. And by the way, the points on the AP free response on your test, it'll be a similar breakdown. Okay, so then the last thing that you need to do on this problem is you will notice it says find the particular solution y equals f of x. If it's written like that, that is signaling to you that you need to solve it for y. And when we solve for y, we are going to just take the square root of both sides. And when you take the square root of both sides, you must, your rule is that you must put in a plus or minus. Here's the part that is really confusing for a lot of people. The plus or minus in this case, we actually are not going to put in both. We put the plus or minus in, but we are actually going to choose the negative answer. And the reason that we are choosing the negative answer is because the y value in an initial condition is negative. So my final answer is actually going to be y equals negative square root of negative x squared over 2 plus 1. Oh, and our last point that we would get is you do generally need to solve for y. So this problem is oftentimes going to be worth either 5 or 6 points. It is a hefty FRQ problem. So if you can master this, you can actually get a lot of points both on your test and on the AP exam. So I have 2 multiple choice questions for you to try. Feel free to pause the video and give them a try. So for number 2, you'll notice that they gave you a slope field and you are given the differential equations. And I want you to notice the difference between 2 and 3. For number 2, they gave you the dy dx's. They gave you the derivative. For number 3, they gave you just the y equals. So just note that. Make sure you know what type of equation you have. So for number 2, I personally think the easiest way to do this question is to look on your graph. Look for anything like I notice at, for example, like 4, 4, and actually everything that's along that diagonal right there, I notice that those all have a slope of 0. So I'm going to choose a few points, see which one have a derivative equal to 0, because the dy dx means the slope. So I'm going to start with 4, 4. And if I plug 4, 4 into x and y for a, I get 8. And I know that looking at that point right there, I do not have a slope of 8. I have a slope of 0. So I can automatically eliminate a. If I look at B, that one has a slope of 0, so that one's okay. Maybe that one's our answer. If I look at C, that one also gives me, if I plug in 4, 4, that one also gives me 0. So that one's okay too, so that's a possibility. And if I look at D, if I plug in 4, 4, I get 4 squared minus 4, which is 12. That one also doesn't work. So we can automatically eliminate A and D. And you can do the same thing. You can choose a different point somewhere else on the graph. It doesn't matter which one you choose. I'm going to choose maybe like -2, -1. Sometimes I'll put some negative ones in there because it'll give me different things. Especially if I have like a squared or something, it's a good idea to choose a negative and a positive, so choose a variety. So I'm going to choose the point -2, 1. And I know already that A and D are not my answers, so I'm just not even going to bother with those. If I plug -2, 1 into B, I get -2 minus 1 equals -3. That doesn't actually look very good because at -2, -1, I have a positive slope. So I'm hoping that C works out. If it doesn't, got to go back and check my math. So I have negative x, which means it's going to become +2 plus 1. And that ends up, sorry, this should be -1. So I just realized I made a mistake on the other one. I should have gotten a +1 right here. So the previous one was a -1. And this one, I should have gotten 2 minus 1, which gives me a slope of 1. That one actually does work. So my answer should be C. For number 3, this asks you, what is the general solution to the differential equation generated by the slope field to the right? And for this one, you'll notice like I said before, I have y equations. Basically, the best way to deal with this problem is just to kind of follow along with the lines that you see there and see which one gives you an equation that matches. So I'm going to show you what I mean. So like, for example, if I were to do a point here, if I were to start at 0, 0, my graph would end up going up and then down. And then when it hit here, it would go back down and then back up. So we want to follow the little slope fields that we have there. And then see what that graph looks like. And you may or may not remember, but it's a good idea to like kind of know what the graphs of sine and cosine look like. This one that has a point at 0, 0, that looks like the graph of sine, and it's a positive graph of sine. So my answer for this one is just going to be E. For question number 4, I have a differential equation right here. This asks me to describe all points in the xy plane for which the slopes are positive. Keep in mind the slope is the dy dx. So we want to know when dy dx is greater than 0. And so we're trying to figure out when is x squared times y minus 1 greater than 0. And we have 2 parts to this question. The first part that we have is this x squared. The second part we have is y minus 1. So if you look at the x squared, that will always be positive as long as you have a real number, which we only work with real numbers in this class, unless x is equal to 0. So this is always positive unless x equals 0. And that actually is really, really helpful because then unless x is 0, the whether we're positive or not is only going to depend on the y minus 1. So I'm going to look at just the y minus 1. We want to know when y minus 1 is positive. If y minus 1 is positive, we will get an overall positive derivative because since we know the x squared is positive, positive times a positive will give us a positive number. Actually, y minus 1 is going to be positive. If you think about doing inequalities, it'll be positive when y is greater than 0. So my answer for this question is, by the way, this was a portion of an old free response question on an old AP exam. So this was, the answer for this would be, so it would be when x is not equal to 0 and when y is greater than 1.